Okay, so for this lesson, we're going to take a look at the slope of a line segment. So like it says, a trucker driving up a hill with a heavy load may be concerned with the steepness of the hill. When building a roof, a builder may be concerned with the steepness or pitch of the roof. A skier going down a hill may be concerned with the steepness of the ski hill. In mathematics, the term slope is used to describe the steepness of a line segment on a Cartesian plane. So, the slope of a line segment is a measure of its steepness of the line segment in a ratio of rise, or the change in the vertical height between points, over the run, which is a change in the horizontal length between 2 points. So, we always assume that in this case, a rise is going to be positive if we count up and negative if we count down. Just like how if we went up our Cartesian plane, then the y values would increase. If we're going down, they're going to decrease. At the same rate, a run is positive if we count to the right and negative if we count to the left, which also works the same way with our x values. As we move to the right, the x values increase. As we move to the left, the x values decrease. So, if we're looking at the examples we have here, each line segment on the grid has endpoints with integer coordinates. Complete the table below. So, if we're looking at line segment AB, we're looking at this line segment here. It wants to know what the rise is, which means that going from point A to point B, how much did I increase my y values? Well, to get up there, I had to go up by 2 from where A was up to where B is. My run is going to be how far to the right I had to head. So I'm going to say that, well, I went 1, 2, 3, 4, 5, 6, 7 to the right. So I had a rise of 2, I had a run of 7, and the ratio is going to be rise over run, or 2 over 7. And there's my slope. If I'm looking at example CD, well, to get from one point to the other, I had to go up by 1, 2, 3, 4, 5. And I went to the right by 1, 2, 3, 4. Which means that I had a rise of 5, I had a run of 4, or a slope of 5 over 4. If I'm looking at segment E to F, well, in this case, I actually had to go down 1, 2, 3, 4, 5. So I'm going to say this was negative 5. And I had to move to the right 1, 2, 3. So I'm going to say that's going to be a positive 3. So I have a rise of negative 5, a run of positive 3, and I get negative 5 over 3 is going to be my slope. If we're investigating the slopes of a line segment, well, we can see that here from A all the way to D is going to just be one straight line. And I have certain points that exist on here, A, B, C, and D. Now, if I'm counting out the points, well, from A to B, so for this first segment here, I had a rise of 2 and I had a run of 3. So my slope was 2 over 3. If I'm going from A to C, then I can see that in this case I had a rise of 8 and I'm going to have a run of 12. The slope is going to be 8 over 12, but that fraction I can reduce down to 2 over 3. If I'm looking at going from A all the way up to D, then I'm going to say, well, in this case I had a rise of 10, and I had a run of 15. 10 over 15 can get reduced down to 2 over 3. And lastly, if I just take a look going from B, starting at a middle point, to C, going to another middle point, then I can see that I have a rise of 6 and a run of 9. And 6 over 9 can also get reduced down to 2 over 3 as a fraction. So when it says, how are the slopes related? Well, they're all the same. When the fraction is reduced. So, the slopes of all line segments on the same line are always going to be equal every single time. As long as it's a straight line, it doesn't matter what points I pick, the slope will always stay the same. The slope of a line representing the graph of a linear relation can be found using slope is equal to rise over run using any 2 points that exist on a line. Doesn't matter what 2 points you pick, the slope is always going to be the same. If I am looking at horizontal and vertical line segments, well, if I'm determining all the slopes of line segment in grid 1, well, going from A to B, I had a rise of 0 because it doesn't change vertically, and I had a run of 1, 2, 3, 4, 5, 6, 7, 8. But 0 divided by 8 is just going to be 0. If I look at going from C to D, then I'm going to have a rise of 0, and I'm going to have a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is also going to wind up being 0. And if you're looking at the pattern we have here, because the y never changes, it's going to be a rise of 0. 0 divided by anything is just going to wind up being 0. So what are the slopes of all the line segments in grid 1? They're all going to equal 0. If I'm looking at line 2 or grid 2, then I have a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm going to divide this by a run of, well, it didn't change. And what you should notice right away is when you put this into your calculator, you're going to wind up with it saying error. The reason for that is because mathematically we can't divide by 0. So we don't say not possible, we refer to that as undefined. And we can see that no matter which one we pick here, 1, 2, 3, 4, 5, 6, 7, divided by 0 is also going to be undefined. And in the last case, if we take 13 divided by 0, this one is also going to wind up being undefined. So, any line segment that is horizontal is always going to have a slope of 0. Any line segment that's vertical is always going to have a slope of undefined. If we're taking a look at positive versus negative slopes, remember, on a Cartesian plane, the rise is positive if it's up and negative if we go down. The run is going to be positive if we move right and negative if we move left. Well, because we typically, when we're doing slope, always read from left to right, then if I'm trying to find the slope of these, I can just pick any points that exist on here and reduce the fraction. So for line 1, I'm going to say, well, here's an exact point, and here's an exact point. Even though it doesn't end on integers, I just need 2 points on the line because the slope is always going to be the same. To get from one point to the other point, I have to go up by 2 and right by 3, which means I have a slope of positive 2 over 3. And when I'm moving from left to right, I'm moving upwards, I have a positive slope. If I take a look at line 2, then I'm going to do the same thing. I'm going to find an exact point that I can see here. I'm going to find another exact point that I can go through, and here I went up by 1, 2, 3, 4, 5, and right by 2. I have a slope of positive 5 over 2. If I'm looking at line 3, then I can take the point here and take the point here, and I can see that I went up by 1 and I went to the right by 3. And I have a slope of 1/3. If I take a look at grid 2, well, for line 4, if I take a point here and take a point here, then to get from left to right, I had to go down by 2, or negative 2, and then right 3, which means I have a slope of negative 2 over 3. For line 5, I'm going to pick 2 points, and here I had to go down by 1, 2, 3, 4, 5, and right by 2. And I have a slope of negative 5 over 2. And here, I take my 2 points, I went down 1, and I went right by 3, and I have a slope of negative 1 over 3. So the easiest way to think of it is if I'm moving from left to right, if y is going up as I'm moving from left to right, it's going to be positive. If y is moving downwards as I'm going from left to right, the slope is going to be negative. If I'm comparing the slopes of lines 1 and 4, they're going to be the negatives of each other, which means that they're going to have opposite signs. I'm going to see the same thing for lines 2 and 5, and lines 3 and 6. So a line which rises from left to right has a positive slope, and a line which falls, or the y values decrease moving from left to right, has a negative slope.